Integrated 1 mini lecture part 2 for 11.1.1 and 11.1 through 11.1.3. I was doing some constructions. If you don't have a compass, what are we going to do if you don't have a compass? You could actually use a string and a pencil. This isn't a string, this is a rubber band, but I mean, you can still, like if you just had a string and you just hold it down, and you can use it just like a compass. Okay, just so you get the idea, or I guess just watch. So I was going to create a rhombus, and hopefully you know that a rhombus, the definition of a rhombus is that it has four sides that are congruent, and they also happen to be parallel. So I'm going to get this on my radius of my compass. I just opened my compass so that one point was on A and the other one's on B. So that's measuring the length, okay, because I'm not going to use a ruler for that. And then I already just drew a random line and another, I drew it extra long on purpose. And I just made whatever angle I felt like making. It was just kind of random. And what I'm going to do is, so this is, I'm going to call it A prime. I'm going to call it A prime, so I'm measuring out this length right here. And there's B prime. And then, well, I don't have any other letters of the alphabet going, but I'll probably call this one D. See, every time this radius that I have on my compass, this is measuring the lengths of the sides. So now I can do kind of the same deal that I did with the triangle, is I can put the needle of the compass right here and make a pretty big arc, because I don't know where it's going to cross. Put the needle on B prime, make a decent sized arc, and now wherever they cross, look, let's call this C, C prime. The distance between A prime and B prime is the same as the distance between B prime and C prime. It has to be, because I made it with this compass. So I hope that you can see these are pretty nifty tools to have. See, I mean, I can prove to you that all the sides are equal because I'm not opening or closing the radius of this thing. So now all I have to do is connect. And then connect. And there's my rhombus. I think I'm going to just keep going until I run out of time on my YouTube video. So here's number 3. So number 3 wants us to make a regular hexagon. Now the word regular means that the sides are equal length. So that means I can probably use this trick again, right, where I open up my compass and then I know every side has to be this length. How many sides does it have to be? You can look that up if you want, or maybe you know that a hexagon has 6 sides. Okay, so how do we start this thing? This thing, there's a couple different ways to do it. The very coolest way to do it, and it only works with hexagons, and you'll see it in every textbook, they'll always do it like this, is they'll make a whole circle with that same radius. Remember, I already just put the radius on my compass. Sometimes I turn the paper. Sometimes turning the paper works better than turning the compass. There. So I made a circle. And now why is this going to work? Well, it just is. Watch. I'll let you figure that out. I'm just going to make a mark. Hopefully I've proven to you that the radius of my circle is the same as the radius of PQ. And watch this. I think this only works with hexagons. I'm going to keep going around the circle, because see, what is this doing? It's making evenly spaced marks around my circle, isn't it? They're evenly spaced, meaning they should be, well, I mean, yeah, that's actually working. Okay, and how many did it magically turn out to be? 1, 2, 3. Whoa, turned out to be 6. That'll never happen with like a pentagon or any other shape. That happens, I wonder if you can figure out why it happens. But just in case you can't, it happens because there's 360 degrees around a circle, and 6 goes evenly into 360. These are making little, this right here, if I were to connect the center to this point, and then connect these 2 points, and then connect these 2 points, that would make a equilateral triangle. And there would be 6 of them, and they would fit inside my circle. So, I know, it's magic. So, but all you have to do, so if anyone ever tells you to make a regular hexagon, just use this circle trick, where you make the circle, and then you make the 6 marks. You can try it. It would be probably fun for you to try it at home, see if you can get a regular hex, or a regular, I don't know, a pentagon, or a octagon, or some other gon. You'll find, if you do try that, you'll find that you'll be going around the circle with the radius, and you'll always get 6, and you won't be able to get 5 like a pentagon needs. So there is your regular hexagon. We drew these out last year. We drew these outside with chalk, because I had we used string actually and a chalk. So you can use string and a pencil if you don't have one of these things. Use constructions to find the centroid of this triangle. The centroid is the intersection of the medians. Well, if you look in your packet, it has some little directions on how to find medians. Medians are perpendicular bisectors. Well, I mean, well, here, it says right here what it is. Oh, wait, it says in, yeah, here's perpendicular bisectors. So if you read all this right here, then you'll probably have a better understanding of how to get a perpendicular bisector of something. If you look in your math notes box in your book, a median is the middle of the side. So it's the bisector of the side. And I think it even says, on number 4, it says find the midpoint of each side. Okay, so it's pretty easy the way you do it. You just go, this will probably be my last one. You guys can do the last one on your own. I make a mark. I put my tip on W and make, I guess you can make a whole circle if you want to. Okay. And then I put my tip on K, and I'm looking for where the 2 circles intersect. And then I'm going to draw a line through it. Okay, so then I'm going to do it again. I think I'm going to do this one bigger so it won't get in the way of all those other marks I already made. I'm going to do this side right here. So we're going to go and then see, I picked it up, and now I'm putting it on D, and I'm trying to find where it intersects, right there and right there, right where the X, I always say X marks the spot. I hope this works out, because we're not robots, and because we might not have the very best quality of compasses, sometimes these things don't work out like they should. Like, see, I moved off of W a little bit, so that might make it a little inaccurate. X marks the spot. Yeah, So mine's not perfect, but it came out pretty close. See these three lines, how they're intersecting right there? See, like that straight line. I'll show you. See that line, and that line? That right there is called the centroid. And you do the last one on your own.